Good evening, students. So, in the last class we studied about the types of fibers and we see about the SA fibers, that is single mode step index fiber. So, we left out with some note part because of the time constraint we are unable to complete that in yesterday's class. So, I need to explain the first of all about the note for the SMSA fiber, and later on I will continue with the remaining MMSA fiber and as well as your another grid index fibers. Okay. So, today's topics we are discussing about the remaining parts of type of fibers and attenuation topic. Okay. So, let us start the concept. So, I am explaining the note, guys. So, those who are late comers also, that we need to concentrate for these points. Please write down the points for SMSA fiber as a note. Why are late comers? Anybody is late? The only concept that we are studying is about the points, note points you are having. So, write down the first point, note SMSA fiber, note. The mode means path. First point, the mode means path, PATH, path. The mode means path, PATH, path we are having. First point. Second point, there is only one path. For light rays. There is only one path for light rays. To take, which is directly down the center of the cable, Repeating the point once again, there is only one path for light rays to take, which is directly down the center of the cable. So, directly down the center of the cable. Next point. The diameter of core is small. The diameter of core is small and delta is usually less than 1 delta is usually less than 1 1%, less than 1%. Next point, it allows only one transverse EM mode, in brackets typically HE11 mode, right. Next point, in single mode fibers, the maximum value of the maximum value of V is equal to, the maximum value of V is equal to 2.405, maximum value of V is equal to 2.405 is equal to 2.405, 2.405, 2.405. Next point. Next point. All light rays follow. All light rays follow approximately. All light rays follow approximately the same path. Approximately the same path. The same path down the cable. Approximately the same path down the cable. Same path down the cable. The same path down the cable. Down the cable, and take same amount of time, and take same amount of time, and take same amount of time to travel the length of the cable, and take same amount of time to travel the length of the cable, and take same amount of time to travel the length of the cable, to travel the length of the cable. Okay, to travel the length of the cable, to travel the length of the cable, right. Next point. Next point. Next point. The cutoff normalized frequency, the cutoff normalized frequency, the cutoff normalized frequency for HE11 mode, the cutoff normalized frequency for HE11 mode, for HE11 mode is Vc is equal to 2.405. See here, Vc is equal to 2.405 nominal cutoff frequency. Vc is equal to 2.405. Vc is equal to 2.405. Vc is equal to 2.405. Right. Next point. There is no ISI, intersymbol interference. There is no ISI, intersymbol interference. Next point, there is no ISI. ISI stands for intersymbol interference. There is no ISI. So there are no errors. So there are no errors. So there are no errors in. So there are no errors in SMSA fiber. There are no errors in SMSA fibers. SMSA fibers. Okay. So this is the points we are having. So right now I will discuss about the MMSA fibers. So writing about the MMSA fiber. MMSA fiber stands for the multimode step index fibers, which is called as multimode step index fibers. So today's class starts from this topic. Yesterday's class we stop at SMSA fiber, and I explained to you clearly about the diagram also, and we see about all the concepts in SMSA fiber. So now we start with the MMSI. The note for that also explained to you. Today starting class is the same topic only. So I hope everybody in the class understood this. We are starting with MMSI. So please just concentrate on the concept by a very simple MMSI fiber. When we talk about the MMSI fiber, we are having multiple modes are present. We have only single mode present in the SMSI, but we have multiple modes. Multiple modes is also called as many modes also. We can call it as many modes are present also. So next important point, that is the second point we can see here. When you talk about the MMSA fiber, there is multiple modes or many modes are present. The next important thing that we can see in here is, we can tell very clearly such that they move in a fashion called as zigzag fashion, many number of modes. So each mode will move in a zigzag fashion. And the third important one after the MMSA fiber, third point is, they move in a zigzag fashion in different ways they are moving, which is called as zigzag fashion we are having. So next point I want to tell to you here is, diameter of core is large. If we talk about the diameter of core is large, is having the diameter is large, diameter of core is large we are having. So after that we will talk about the another fiber which is called as your MMSA fiber. So next important point I can tell to you here is, that is nothing but the number of modes we are having, V is equal to 2 pi A by lambda, 2 pi A by lambda into numerical aperture. We can also write like this also, your V is equal to 2 pi A by lambda into N1 into root of 2 delta. And we can tell about the another important point, that is called as the number of modes. The number of modes. If you see about the number of modes is also called as mode volume. The number of modes, or it is also called as the mode volume we are having. The number of modes or mode volume is given like this. So mode volume is present. So when you talk about the mode volume, we can write it as Mn value, Mn is equal to alpha divided by alpha plus 2 into V square by 2. Already we studied in the last topic. And obviously we knows about the value of alpha. Your value of alpha is equal to that of infinite, that is equal to infinite. Why? Because for our step index fiber. Please recall this concept, already we studied in the last topic. In last topic I told to you such that your value of alpha is equal to infinite for step index fiber. How we get that alpha value? The value of alpha will be obtained by differentiating the profile shape. Once you differentiate the shape of the profile and take the magnitude of that particular differentiated profile, we will use the value of alpha. Such alpha is equal to infinite, which is called as, for our step index fiber, it is equal to infinite we are having. So after that I will explain you about the next one, which is called as number of modes. Dekho bhaiya, Mn. I am taking alpha as a common in the denominator. The value becomes as 1 plus 2 by alpha. In the denominator I am taking common. Alpha divided by alpha into 1 plus 2 by alpha is the value we are having. So which is multiplied with V square by 2. This alpha and alpha get cancelled out to each other, and I am substituting the value of infinite. Then that become 1 by 1 plus 0. When I put infinite, 2 by infinite is equal to 0, multiplied with V square by 2, and that value is equal to V square by 2 is present, which is given as Mn, number of modes. Number of modes is equal to V square by 2 we are having. It is called as Mn is equal to V square by 2 is present. This is called number of modes or mode volume. So Mn is equal to V square by 2 we are having. That is what said to be called as the point number 5. And now coming to the point number 6. Okay, light does not travels with uniform velocity, light travels with non-uniform velocity. Whenever the light travels with non-uniform velocity, the first important thing that we can have here is, it was going to be creating the dispersion in the pulse, okay, which is having the pulse spreading. Your pulse spreading is occurs. Due to the pulse spreading, what happens is, it is very clear, we are having the ISI, inter-symbol interference, because of pulse spreading, which leads to the errors. So we can tell that errors are high when we talk about the MMSI fiber. There is no errors in SMSI fibers, but we have an errors in MMSI fibers are considered. Okay, so please see here guys, there is ISI, so errors are very high we are having, that is the point number 8. And the next important, that is point number 9, the number of modes, the number of modes depends on, so the number of modes are depends on, so depends on, I can tell the points neatly in the note I am writing here. First one is called as the core diameter or core radius, which is given as 2a. Second one is called as delta. So third one, delta or numerical aperture. So whatever it may be guys, we can talk about the delta or numerical aperture. So writing it is equal to that of numerical aperture. So third one, after writing the first point, it is 2a, second one is called as numerical aperture. So third important one, after writing the numerical aperture, we are studying about the next one, which is called as refractive index of core and clady, that is N1 and N2, and after that it is called as fourth one. The fourth one is said to be called as it is given as like this, which is said to be called as the value of frequency or wavelength, which is given as lambda or frequency by a. So your number of modes depends upon these parameters. If you see here, one is called as V depends, number of modes depends, Mn is equal to V square by 2. If V increases, Mn increases. If Mn is going to be increased, means V increases by increasing the A and increasing the delta and decreasing the lambda. By decreasing the lambda, we get the V value will be increases. This will gives about the number of modes. The number of modes are completely depending upon these parameters, that is 2a, numerical aperture, N1 and N2, and also wavelength or frequency. I request the students, please copy that part, all of you. Copy Nana. So once copying is completed, put a message such that copying is completed. Right. I hope everybody in the class copied this part. I got a message from few students. Now I can explain the diagrammatic representation. Please see here. This is called as the diameter of the core. And this one is said to be called as diameter of the clad. This is called as the axis of the fiber, okay, which is called as axis of the fiber we are having. Now, concentrate here. The diameter, the core diameter is very, very high. So, showing you the front view. This is the front view, showing you the front view of your fiber. This is the front view of a fiber. This dot indicates axis at the center. Axis at the center. This dot indicates axis at the center. After writing about this formula, that is this way, we understand clearly such that this is called as the radius r. Your radius r value is equal to a. We are having radius r value is equal to a. Now, I will explain you the another part here, how the light was passing into a fiber. So, requesting all the students to follow this red color pen so that you get a clarity. And infrared light was moving. This is first mode. This is second mode. Similarly, this is third mode. This is called as the fourth mode we are having. Similarly, another mode will also travels at the center. Clear, Nana? We observed very clearly such that it is going to be having a mode called as meridional ray is passing. See, the rays are crossing the axis and the rays are passing along the axis also. We studied in the classroom, yesterday's class, about the three types of rays, Bhaiya. One is meridional rays, other one is axial rays, and another one is so called skew rays. So, axial rays we studied in the yesterday's class in your SMSI fibers, and he was talking about today's class. We are discussing about the meridional rays. Okay, so the light was passing in your multi-mode step index fibers with the help of a meridional rays we are having. So, I hope everybody in the class understood this. This is the meridional rays we are having. So, light is passing through the meridional rays we have. So, next important point. So, Bhaiya, dekho Bhaiya idhar, I am giving a small pulse. The pulse was going to be having more number of light signals are present. All these modes are present within this light, pulse of light. And see, this center fiber will move very fastly and the remaining fibers are going to be moving slowly. Then there must be definitely have a difference of reaching the modes at the end of the fiber. Definitely at different times they will reach. The one who reaches fastly is this center mode, which is moving will reaches very fastly, and the remaining modes will take some time to reach to the end of the fiber. But what happens here is, if you observe clearly, one thing is, that is, so whatever the pulse I am giving, all the modes of light present in this pulse reaching to the other end, you are having the pulse spreading. This is called as pulse spreading we are having. Already I told to you, because of this pulse spreading we are having a problem called as ISI, inter-symbol interference. So, inter-symbol interference has comes into the picture, and once the inter-symbol interference has comes into the picture, we know very clearly such that it is having errors will be present. Because of this pulse spreading, different modes are traveling with different velocities. Different velocities reach at different times. Reaching at different times, pulse was spreading, and the spreading in the pulse will create a problem of ISI. ISI in turn leads to the errors. And this point is very important. You observe clearly, in SMSA fiber there are no errors, but in MMSA fibers we are encountering with the errors. Okay, I hope everybody in the class understood this. So, still if you have any doubt is there, please put it in the chat box, Bhaiya. So, and concentrate on the next topic. It's also quite important one. So, please check it here. Bhaiya, at this interface I am talking about the at this boundary condition of your core and clady. You study in the classroom, it is called as core, it is called as clady we are having. So, this is also called as the clady we have, which is called as N2 is present. Now, I am drawing the diagram here, which is said to be called as a simple diagram is boundary is drawn here. A boundary is drawn here. A boundary is the line which is going to be drawn in between the two mediums. भैया ऑब्जर्व क्लियरली भैया, दिस मीडियम इज इक्वल टू कोर, इस कोर का मीडियम है, एंड दिस मीडियम इज इक्वल टू N2, N2 मीन्स क्लैडी का मीडियम है. सो वी हैव कोर का मीडियम एंड क्लैडी का मीडियम, दो मीडियम्स है. ओके, इन दोनों मीडियम का बाउंड्री है, बाउंड्री इज द इंटरफेस बिटवीन द कोर एंड क्लैडी का पास बाउंड्री दिया. नाउ जस्ट ऑब्जर्व इट, दिस लाइट रे, सी दिस लाइट रे, assume I am talking about this light ray. This light ray is going to be come and hit the so called the boundary. Line drawn perpendicular to the boundary is called as normal. We study in the yesterday's class also. This is the line drawn perpendicularly to the point of intersection is said to be called as which one? Normal. So भैया ये normal है, normal डालिए. And this is the angle maintained by this one is called as theta c. Obviously students studied here in the classroom. So if you write like this, this part is called as which value? Nana, theta c, and that theta c I am showing here. Okay, now please observe carefully guys. Whenever the light ray, observe here I am using the yellow color pen, please concentrate. Whenever the light ray is incident with an angle greater than theta c, that means ray A, that will be take total internal reflection. It is coming total internal reflection. So light is confined in the core itself only. The light is confined within the core itself only. Whenever the angle of incidence is greater than theta c. Okay, greater than theta c. Similarly, I am drawing with another color pen, which is given with blue color bhaiya. So whenever the light ray is incident, so whenever the light ray is incident here, so see here, whenever the light ray is incident with an angle greater than theta c, then definitely it will also takes the TIR, take the total internal reflection, TIR is present. So this is called as ray B we are having. So bhaiya, it is called B, it is called as A. So to have a total internal reflection, definitely your different light rays are having, they will be hit at the interface with an angle greater than theta c. With less than theta c means they will definitely go into be lost state. I am showing you the case by using a pen called as at some different color. Now see carefully. Whenever the light ray was incident with an angle less than theta c, see light ray was incident with an angle less than theta c, then what happens is the light ray will not get reflected, the light ray will get refracted. Already we studied in the classroom, refracted in the sense means it moves into the another medium, but reflection is nothing but it comes into the same medium. So bhaiya, refraction will takes place. Why refraction takes place? Because at ray C, what happened is you are going to be having the ray which is going to be incident with an angle less than theta c we are having. With an angle less than theta c it is present. So this is what said to be called as ray C we are having, which is called as the so called refractive index we have, and this ray C which is goes into the clady, this ray is lost state. So we have faced two problems bhaiya. The first problem is nothing but you are having the pulse spreading. Pulse spreading makes that errors are high. We are having errors are high is present. And the second important thing we can have is the ray is lost state. The ray is lost state. So this is what the drawbacks of your MMSI fiber. So we are not talking about the MMSI. So we need to have a fiber which is having the characteristics to be have no error and also rays cannot be lost. Okay, please bhaiya copy this part all of you diagram. right. So, complete copying means I will tell you the points. Yeah, write on the first point in MMSI. First point in MMSI as a note. Note first point. In multi-mode propagation, in multi-mode propagation, in multi-mode propagation, there are many higher order modes possible. There are many higher order modes possible. Many higher order modes possible. And light rays propagate down the cable. Many higher order modes possible and light rays propagate down the cable. Light rays propagate down the cable in a zigzag fashion. In a zigzag fashion. Light rays propagate down the cable in a zigzag fashion. In a zigzag fashion. Right. Next point. The light rays that strike the core or claddie interface, that strike the core or claddie interface at an angle less than the critical angle, at an angle less than the critical angle, at an angle less than the critical angle, enter the claddie, enter the claddie and lost, enter the claddie and lost, enter the claddie and lost. In brackets write down ray C, R-A-Y, ray C, okay, ray C. Write down. Next point. Next point. The number of modes possible. The number of modes possible for a multi-mode fiber depends on. The number of modes possible for a multi-mode fiber depends on. Fiber depends on. First point. Frequency or wavelength. Frequency or wavelength. Frequency or wavelength of the light signal. Frequency or wavelength of the light signal. Second point. The refractive index of core and clady, the refractive index of core and clady, third point, core diameter, fourth point, numerical aperture, fourth point, numerical aperture, Okay, so write on the next point. All rays do not follow the same path. All rays do not follow the same path. And do not take the same amount of time. To travel the length of the cable. To travel the length of the cable. Okay. So, to travel the length of the cable. Right. Next point. To travel the length of the cable. Next point. In multi-mode step index fiber, due to non-uniform velocity, in multi-mode step index fibers, due to non-uniform velocity, the pulse spreading occurs, and errors are high. The pulse spreading occurs and errors are high. I hope everybody in the class copied the part, diagram, theory, everything. This is about MMSA fiber, multi-mode step index fiber. So, MMSA fiber. Now, we can see about the next one, the next concept, that is called as cutoff wavelength. That is given as a cutoff wavelength. I am explaining here, all of you please concentrate. Cutoff wavelength is given as lambda c. We study in the classroom like this: V is equal to 2 pi a by lambda into numerical aperture. And we can tell about the value of V. V is equal to 2 pi a by lambda into numerical aperture is present. Cutoff wavelength is lambda c, replacing your lambda with lambda c. Replacing lambda with lambda c. And V is replacing with Vc, that is 2 pi a into numerical aperture whole divided by Vc. Vc is called as the cutoff normalized frequency. Lambda c is called as the cutoff wavelength. So, that Vc, what are the value of Vc we are having? So, I hope everybody in the class complete the diagram, Nana. Drawing the diagram, this one. So, please observe here carefully. I am talking about the next one. So, here the value is present like this, which is given in this way. Vc, what is the value of Vc, Nana? Already we studied in the classroom. Your Vc is equal to 2.405. We studied in the last topic also, your Vc. So, lambda c is equal to 2 pi a by value is equal to 2.405 into numerical aperture. This is called as cutoff wavelength. It is called as cutoff wavelength. For single mode operation, definitely your operating wavelength will be greater than lambda c. Operating wavelength will be greater than lambda c. What is the operating wavelength we are having? Lambda, that should be greater than lambda c we are having. And for multi-mode operation, if you talk about the multi-mode operation, for multi-mode operation the lambda should be, operating lambda should be less than the your cutoff frequency. Then only we can get the multi-mode operation will be possible. So, this is about the cutoff wavelength we are having. So, this completely this topic is with respect to your step index fibers. Yesterday's class I discussed about the two things, Bhaiya. So, there are two types of fibers are present based upon the materials and based upon the refractive index profile. Based upon the RI profile also we are having two types of fibers. One is called step index and another one is called as the gradient index fibers. In step index we have two types of fibers, one is SMSI, other one is MMSI. So, we discuss about the SMSI and MMSI fibers. So, this is completely about our step index fibers we have. I discuss about all the points and please copy this one about the operating wavelength also. So, wavelength. Right. So, right now I am explaining about the next topic, that is called as gradient index fiber. This is called as gradient index fiber. So, discussing about the next one, which is called as gradient index fibers. If you talk about the gradient index fibers, the most important thing that we can see here is by a core is non-uniform. In step index fiber both core and clady are uniform, but here core is non-uniform, but clady is uniform. Hope everybody in the class understood this. In step index fiber both core as well as clady are uniform, but in gradient index fiber your core is non-uniform and clady is uniform. Now, coming to the second important point, refractive index of core is high at center, and decreases and decreases towards the clad and decreases towards the clad. This is second point. Third important point, light will travels with refraction rather than reflection. Generally the principle that is present in the optical fiber cable is TIR, total internal reflection. But the total internal reflection is not satisfied by the your fiber, which is called as your gradient index fiber. It is takes the refraction. Refraction in the sense means continuous bending of the fiber. We are having continuous bending of the fiber is present. That is continuous bending of the light ray, which is called as continuous bending of the light ray is present. So next one, after this we can see about the next point, that is point number 4. Writing about the fourth point. If you see that point number 4 we are having, when we talk about the gradient index fiber, it maintain almost uniform velocity. It maintain almost uniform velocity. Almost uniform velocity will be maintained. And next important point that I want to tell to you here is about our gradient index fiber is, because of almost uniform velocity, you can tell that ISI is less. Your ISI is less. Not no ISI, it's not no ISI, ISI is present, but ISI is less value, very small spreading is there, intraseminal interference is very small. And now we are discussing about the next point, that is said to be called as the point number 6. If you see this point number 6, so almost uniform velocity, ISI is less we are having. And the next important thing that we can observe here very clearly is errors are less. Errors are less we are having. So this is the complete concept we are having for the gradient index fiber. So all of you please observe the diagram. So these points are written here. And one more thing also I will tell to you, that is the refractive index. The refractive index is given like this. Seventh one, refractive index is a function of R. R is called as radius of the core. R is the radius of the core we are having, N of R. N of R is equal to value N1 into 1 minus 2 delta into R by A whole to the power of alpha whole to the power of 1 by 2. By alpha is called as the shape of the profile, also called as alpha as the profile parameter. Okay, also called profile parameter, shape of the profile or index number. So N1 into 1 minus 2 delta, delta is called relative refractive index difference, R value changes, this will changes. Whenever your value of R is going to be less than A, this is the formula for gradient index fibers. For example, R value is greater than or equal to A, the refractive index value is equal to how much, Nana? N2. Remember carefully guys, students, you study in the classroom, yesterday's class like this, for reference I am writing. Bhaiya, N of R value is equal to N1 whenever your R value is less than A. Whenever your R value is less than A we are having. Okay. Whenever your R value is less than A we are having. So we write like this, that is N1, your R value is less than A we are having. So R value is less than A is present. It is equal to N2 when R value is greater than or equal to A. Then what you study in the classroom is like this, your core refractive index, clad refractive index is uniform. Yesterday's class, Nana, yesterday's class is uniform. Then students will understand very clearly such that both are uniform, that is going to be not changing, uniform for the entire value of the radius of the core. It is also uniform for the entire value of the clady also. For core and clady, it is going to be uniform we are having. But this is not the case. You can find out as per the concept, it having core having non-uniform, which is changing with respect to the R value. with respect to the radius of the core, your refractive index changes. At center it is high and at the edges it will decreases. Refractive index will decreases when you are moving towards to the edges, and that is the concept lies behind the your graded index fiber. And of course I can show you to you with an examples also. I hope everybody in the class understood the difference between this is graded index bhaiya and this is called as step index. It is for your SI, step index fiber. So clear? Okay, right. So give me some amount of time so that I can come back again to this slide to make some derivation part of this one. Okay, and also number of modes to be present. I will draw the diagram. So प्लीज़ भैया थोड़ा जल्दी लिखो इस स्लाइड के लिए, हमको डायग्राम ड्रा करेंगे एंड एक्सप्लेन करेंगे. See here, we are talking about the diagram. Please all of you observe this one. So bhaiya, core refractive index, clary refractive index. This is the fiber. Now this part is axis of the fiber we are having, center of the fiber, please concentrate, and this is called as length of the fiber. So length of the fiber is given as L. So this is L, capital L, length of the fiber we are having. So after talking about this length of the fiber, we are discussing about the next one. So which is given like this. The refractive index at the center is very high, which is called as N1. The refractive index was decreases if you are going towards to the value, and that is called as N1 dash. That is called N1 dash. See by N1 dash. And the refractive index was simply decreases if you reach towards the clad, N1 double dash. Then what is the condition? The condition is like this: N1 is greater than N1 dash is greater than N1 which value? Double dash, N1 double dash. The refractive index at the center is high and becoming less when you are moving towards to the which one? Towards to the so called said to be the edges of the clady, or reaching towards the clady, it will decreases. Okay, the same thing is happens at the downside also. Dekho bhaiya, this is what we are having. So this is what said to be called as N1 and N1 double dash, that is N1 dash and N1 double dash. I hope everybody in the class understood this. Now just observe carefully, I am drawing here the side view is completed, the front view I am drawing bhaiya. Refractive index of core and refractive index of clady we are having. So this is the part we are having. And this is what said to be called as your refractive index. Just observe carefully. At center, the value is equal to n1. I hope everybody in the class understood this. And here the value is equal to n1 dash, bhaiya, clear bhaiya. And this value is equal to n1 double dash we are having. That value is called as n1 double dash is present. So we can write that this value is going to be equal to that of n1 double dash we have, which is called as n1 double dash is present. So, and the refractive index of this claddie is equal to n2, that is equal to n2 nana. The claddie refractive index is equal to n2. So this is what we seen in the diagram. So the refractive index is not uniform, the refractive index is changing according to the moving towards to the edges. At center it is high, but when moving towards the edges it is decreasing. Okay, and next point, when the light is propagating into the gradient index fiber, red color light, dekho bhaiya, infrared light, it is not having refraction, but it is going to be having a continuous bending. See bhaiya, it is having a continuous bending. So continuous bending is present. And because of that continuous bending, what happened is the light is going to be having refraction rather than reflection. Actually, it is not taking total internal reflection, it is taking refraction, moving from one medium to another medium and again coming back from another medium to this medium, like continuous bending was present. Okay, that is the second point I need to explain to you. But coming to the third explanation, third point, very important, just concentrate. We study in the classroom refractive index n. Please tell the formula. What is the formula for n? Nana? I ask you to refer also. Bhaiya, bolo bhaiya, kya hai? जोर से. N is equal to C by which value? V. Now just understand this concept. You know that when value is increases, okay, the velocity will decreases. If for example velocity n value is less, velocity is high. Observe carefully the light. Observe carefully guys, the light at center. See, the light is traveling at center. At center, your refractive index is high, then velocity is less. So the light rays will travel with less velocity at center. The light rays travel with less velocity at the center. Am I clear? They travel with less velocity at the center. So next one is, I will tell like this. Whenever the light rays are moving away from the center, see the refractive index is decreasing. Bhaiya, refractive index is decreasing, automatically velocity will be increasing. So what we observed from this explanation, at the center, your light rays will travel slowly, and at the edges of the fiber, your light rays will travel fastly. So traveling slowly at the center bhaiya and traveling fastly at the edges, which is going to be maintained by the gradient index fiber, light travels not with uniform velocity, it is going to be almost having a uniform velocity. Why? See, observe that if you are moving here with very low velocity and here very fast velocity and again low velocity and again fast velocity, low and fast like this, so slowly, fastly like this bhaiya, then what happens is almost if you take an average of the speed of all the velocities, you will get almost constant velocity. That's why it travels with almost constant velocity. So whenever a light pulse is given, the dispersion that is present in the light pulse is very less. It's not like a very huge dispersion is seen in MMSA fiber is not present in the gradient index fiber. I hope everybody in the class understood this. So what are the points I explained to you in the class are once again explained to you here in the diagram. If you just observe that, if you just observe that, so dekho bhaiya, if you just observe that, you find the same thing here. See, core is non-uniform, clad is uniform, refractive index of core is high at center and decrease towards the clad, explained to you. Refraction, continuous bending is explained to you. Almost uniform velocity, explained. Errors are less because pulse spreading is less bhaiya. So this is the concept lies behind the refractive index. And one more thing bhaiya, I need to fill this part. See, I will just want to write here. I want to explain that to you once again. If you are talking about if you are talking about the So now see here, if you are talking about this one, see at center, bhaiya, at center what happened to the value of r? At center the value of r we are having is equal to 0. So at center the value of r is present, so r value is equal to 0. And if you are moving towards the edges, r value will changes means refractive index will changes. If is equal to r is equal to a, here your value of r is equal to a, and here what is the value, nana? Your value of r is equal to 0. What is r? R is called as the radius of the core. R value is equal to 0 at center, and it is going to be equal to a at the end of the core, because total radius of the core is equal to a. Clear ना? Total radius of the core is equal to a. So भैया देखो भैया, इधर ध्यान से सुनो, all of you please observe this one. Dear students, here the refractive index is present like this. Now see here, I am just drawing the diagram. Refractive index of air is constant. At this boundary point, refractive index was changing from N0 to N2, already shaded by us. N2 is greater than N0, so N2 value is greater, and maintains constant N2. After that, this is the refractive index. See, this refractive index, this refractive index, this refractive index are touching to each other, and it comes to here, again maintain constant, and this is the value we are having. Okay, and this is the value we are having. What is this called as? This is called as the parabolic profile. Just observe the shape. The shape looks like a parabolic, bhaiya. It looks like a parabolic profile. What is this one? It is called as parabolic profile. This profile is called as parabolic profile. Okay, so the step looks yesterday's class we see the profile that looks like a step. We call it as a step profile. Okay, so now it is called looks like a parabolic. See, the shape looks like a parabolic, भैया parabolic shape है हमारा पास, parabolic आ गया, so अच्छा parabolic है. So this parabolic के लिए क्या करेंगे means we can tell about the important thing. Shape looks like a parabolic, so we can write in this way. Okay, so parabolic, we write the parabolic profile. How the parabolic equation is given? Already we studied that parabolic equation is given as y is equal to x square. Okay, the differentiation of this one, that is dy by dx is equal to 2x by is equal to 2x. Now, what is the magnitude of this one? Magnitude of differentiation dy by dx magnitude value is equal to 2. So the profile shape alpha value is equal to 2 we are having. How we got alpha is equal to infinite? Because yesterday's class we have that your shape looks like unit step function u of t. So dy of divided by dt is equal to differentiation of du of t divided by dt by du of t divided by dt is equal to delta of t by So mod of dy by dt, mod value of this one is equal to infinite, because the magnitude of impulse function is equal to infinite. So you observed this part in the yesterday's topic and this part in the today's topic we are having. I hope you understand everybody in the class, because due to the time I am not able to explain this concept in the yesterday's class. The reason how we get alpha is equal to infinite, I just told orally to you without writing anything on the board. Some students will have a doubt, they put and asked also in the chat box, but I told such that I can explain that in the today's class. That's what we are seeing in the today's session, bhaiya. Everybody, I think you got a good clarity regarding that. How you write your alpha is equal to 2. The parabolic equation, write down your parabolic equation and differentiate the parabolic equation and take the magnitude, that is the coefficient value we can take it. The coefficient value we are having, the magnitude value is equal to that of 2. Therefore, we can write our alpha value is equal to 2 for a parabolic profile. I hope everybody in the class understood this. So then I can go for the next one. So the next profile I am showing here. So bhaiya, I am removing all this part which is not required for us, only conceptually only. So next one is, we see the shape I am using with another color which is yellow color. Bhaiya, we are having the value which is said to be called as this is called as profile. This profile is called as triangular profile. It is called as triangular profile. If you write a triangular equation, so you write a triangle equation, y is equal to that of the value is equal to that of 1 plus mod x by value is equal to t, where capital T is called as your width by so capital T is called as the width we are having. So everybody in the class understood this, equal to t. If you differentiate this that is equal to dy by dx, you are going to be getting the value called as 1 plus mod of x, and that value is equal to that of line equation, putting minus t to t. So we get a line equation like this. So the triangle will present like this. This is the triangle. Differentiation, we get the magnitude value is equal to 1 is present, and that alpha value is equal to 1, which is called as triangular profile they are having. For triangular profile, your alpha value is 1. For parabolic profile, your alpha value is equal to 2. So that's the two types of profiles we are having. So parabolic and triangular profile. The default profile, nothing is specified in the question, means we will take the default profile as the parabolic profile only. We consider it as a default profile we have. So please draw this diagram. Once it's completed, please put a message. Right. So all of you see here, I am explaining you about the next concept. Bhaiya, we studied this formula here for refractive index. So this one refractive index formula. So n of r is equal to n1 into 1 minus 2 delta into r by a of alpha to the power of 1 by 2. So please see here, I am talking about the first case. So when I am taking the value of your r is equal to 0, by r is equal to 0 means obviously you knows that if r is equal to 0, you are having here at center, see I wrote here r is equal to 0, at r is equal to 0 center the refractive index value is equal to how much, Nana? N1, the refractive index value is equal to N1 we are having. So the same refractive index will be obtained here also, and that value is given like this. So please see here, your r value is equal to 0. So r value is equal to 0. So dear students, I request each and everyone, so concentrate here on the subject. R value is 0. So we can write n of 0 by a n1 into 1 minus 2 into delta, because r is less than a, r is less than a, I am taking r is equal to 0. For r is equal to 0 I am taking. In the numericals I will explain center points, 1/3 of the distance or 1/4, 3/4 of the distance, how they covered, I can explain those things in the classroom. Okay, in numericals you will see. So taking at n is equal to 0, at n is equal to 0 means this value become equal to 0 by a, so 0 whole to the power of 1/2. So anything to the power of 0, this is 2, 1 minus 0, 1 to the power of 1/2, the value is equal to n1. Now when you take about the second case, capital small r is equal to a, see I am taking this case, when r value is equal to a, by when r value is equal to a, just observe here, r value is equal to a in the sense means you substitute the value of a, so n of a, we want to get n2, that n2 I am showing how it gets, the value is equal to n1 into 1 minus 2 delta into value of a, so a by a whole to the power of alpha into 1/2, but just observe it, n1 into 1 minus 2 delta into a by a is equal to 1, so this value is equal to 1/2. Now this is equal to n1, n1 into 1 minus 2 delta, that is 2 into delta, delta is equal to n1 square minus n2 square divided by 2 n1 square, already we studied in the classroom. This 2 and 2 will get cancelled out to each other, and what I am trying to doing here is I am taking this n1 to the other side, that is n1 into I am taking LCM n1 square minus n1 square plus n2 square, multiplying with the negative sign, minus into plus is minus, minus minus is plus, and this value whole divided by the value is equal to n1 square to the power of 1/2. Now this one and this one will get cancelled out to each other, n1 and n1 will get cancelled out to each other by a, so n1 square minus n1 square. So this value is equal to that of n1 into, just observe carefully. So this is written as n2 by n1 of whole square, which is written as n2 by n1 of whole square. This whole square and 1/√2 will cancelled out, n1 and n1 is also cancelled out, then the net resultant output value what you are getting is equal to n2, that is n2. I hope everybody in the class understood this by a, so any doubt regarding that, so please copy it, copy this part also, I will explain the remaining thing about the MMGI fiber. You please copy this part, Nana. A.R. Singh, please copy this one, I will show the diagrams to you later on, you please copy this part. Please anybody copying, please copy these diagrams also and this part also. So diagram. Right. Okay. So I will explain you the next concept. So I hope everybody complete this diagram also. I am explaining you the MMGI fibers. Bhaiya, MMGI fibers, multi-mode graded index fiber, which is given as MMGI fiber. When you talk about the MMGI fiber, this is the fiber said to be core as well as claddy. So writing about our core and as well as the claddy. So showing like this. So this part, and after that we are writing the clad and the core, which is shown in the figure. This is core and this is clad. By at center the refractive index is very high. When moving to the edges, the refractive index is very less. Please observe the first thing. This is the ray. Instead of reflection, we are having continuous bending. Bhaiya dekho bhaiya, continuous bending, having a continuous bending. Instead of reflection, we are having a continuous bending. I hope everybody in the class understood this. Continuous bending is present. Not reflection, refraction, refraction. Bhaiya, refraction, not reflection. Am I clear? That is the first mode. We are having another mode. See, multiple modes are present. I hope everybody in the class understood this. Here also continuous bending. So bhaiya, we are having the continuous bending is present. This is called continuous bending is seen. Right. So after that I am using another color pen to identify that another mode bhaiya, as a blue color I am using. So this is the blue color mode we are having, which is shown in the figure like this. And this is the blue color mode, which is shown in the figure like this. And this is what the blue color mode we are having. Clear na? Okay, this is another mode. The same I can show the another mode like this, which is present. This is the mode we are having. Another mode we can see as shown in the figure like this. Different modes bhaiya. Like this you can see the modes. Like the remaining modes are also be there. Just observe the shape. The shape what you are getting because of continuous bending is parabolic shape. Getting is parabolic shape. That's why the default shape we are taking is a parabolic. The default shape we are taking is the parabolic shape here bhaiya. That parabolic profile is nothing but an which is present as a default for MMGI, that looks like a parabolic shape we are having. Okay. So this is about MMGI fiber. We study in the classroom like this. Number of modes formula. Dear students, can you please tell me what is the number of modes formula? Mn is equal to, yeah, very good, alpha into alpha divided by alpha plus 2 into which value? V square by 2 is the formula we are having. I hope everybody in the class understood this one, right? So Mn is equal to alpha divided by alpha plus 2 into V square by 2 is the value we are having. So after writing this part, I will explain in this way. Talking about the parabolic profile, we are considering a parabolic profile. Bhaiya, for parabolic profile, what is the value? Alpha is equal to 2. When you put the parabolic profile, for parabolic profile, your alpha value is equal to 2. The number of modes Mn we are having is equal to 2 divided by 2 plus 2 into value is equal to V square by 2. These two values will get cancelled out and that value is equal to V square by 4. For parabolic profile, the number of modes we are having is equal to V square by 4 is present. The number of modes we are having is called as V square by 4 is present, which is called for your parabolic profile, which is called MMGI. So next one is called as a profile said to be called as a triangular profile. So we are writing about the triangular profile. If you talk about the triangular profile bhaiya, we study in the classroom alpha is equal to 1. See here, alpha is equal to 1. So the number of modes, dear students, please tell the formula. Mn is equal to alpha divided by alpha plus 2 into v square by 2. Substitute in the value of your alpha, that is equal to 1 divided by 1 plus 2 into value is equal to v square by 2, that is equal to v square by 6 is present. So the number of modes Mn is equal to v square by 6 we are having, it is called as v square by 6 is present. So the number of modes we are having is called as v square by 6 which is given as triangular profile we have. So in MMGI fiber, if you observe clearly, you are having first profile is called parabolic profile, number of modes are v square by 4, and second profile is called triangular profile, number of modes is equal to v square by 6 is present. I hope everybody in the class understood this. So Bhaiya, please copy this one. That is the modes we are having in MMGI. Under the last concept in types of fibers, I will explain that and we will solve some numericals. So get ready with your calculators. We will solve it by using the calculators. Yeah, please copy it. I will tell a note to you. Once copying is completed, just put a message. Is it audible? Is it audible? Students, read on the first point. Read on the first point. The gradient index fiber, first point, in gradient index fiber, in gradient index fiber, the refractive index is not constant. In gradient index fiber, the refractive index is not constant, is not constant. In the core, is not constant in the core, is not constant in the core, full stop, is not constant in the core. Next point, the next point, the refractive index, the refractive index is highest at the center, is highest at the center, is highest at the center of core axis, is highest at the center of core axis, center of core axis, core axis, and decreases towards the outer edge, 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 towards the outer edge. Next point, light rays propagate down this fiber, light rays propagate down this fiber, down this fiber through refraction, through refraction rather than reflection, through refraction rather than reflection, and continuous bending of the, and continuous bending of the, and continuous bending of the light rays, and continuous bending of the light rays, continuous bending of the light rays. Okay. Next point, next point, the light rays propagate down the fiber, the light rays propagate down the fiber, down the fiber, almost travels with the, almost travels with the, travels with the uniform velocity, travels with the uniform velocity, and take approximately the same time, and take approximately the same amount of time, and take approximately the same amount of time, same amount of time to travel the length of the fiber, approximately the same amount of time to travel the length of the fiber, to travel the length of the fiber. Okay. So these are the points which are very important. I need to talk about default parabolic profile and all those things. Okay. I think copying is completed. But yeah, next topic. So please see this one, guys. Listen carefully. Later on we can see about the next topic as conversion. Bhaiya, concentrate bhaiya. Some doubts asked by some of the students. A.R. Singh asked one doubt. Yesterday also one student asked one doubt. Sir, the number of modes are not getting by putting V value is equal to 2.405 is equal to 1 mode. Okay, I am not able to remember the name, but anyhow, okay. So I will explain to you about this part. Please see here. Conversion from multi-mode to single mode. Why? See, single mode fibers are always going to be creating a problem such that we have an pulse spreading. Pulse spreading was creating a problem of your ISI, intrasymbol interference, and intrasymbol interference was going to be definitely making the impact of errors will be present. So to reduce that, what we are having is only alternate is we have single mode step index fiber. So alternative single mode step index fiber, the only one mode is present, and the whatever the velocity that maintain is uniform velocity, there is no ISI, there is no errors. So that's why we are always converting all our multi-mode fibers into single mode fibers. Okay, all your multi-mode fibers into single mode fibers. Now just listen carefully, Nana. Number of modes, Mn. Mn is equal to alpha divided by alpha plus 2 into value is equal to V square by 2 is considered. It's called as V square by 2. Please observe carefully, all of you. I am taking this to the other side. So we are taking your Mn value is equal to 1 because single mode means number of modes is equal to 1. I am putting M is equal to 1. Why I am writing like this? Because of which mode? Single mode conversion. Single mode means number of modes will be equal to 1. So 1 value is present. So that is equal to alpha divided by alpha plus 2 into V square by 2 is the value we are having. So therefore alpha plus 2 into 2 divided by alpha is equal to V square. Observe carefully, your V square is equal to that of, your V square is equal to, it is given like this, that is 2 into, just observe it, we are splitting it, alpha by alpha plus 2 by alpha is present. This will cancel out, equal to 1, that is equal to 2 into 1 plus 2 by alpha, it is equal to V square, taking the V, the rooting on the both the two sides, that is root 2, 1 plus 2 by alpha whole to the power of value is equal to 1 by 2 is present. So V square that is equal to 2 and root 2, that is 1 plus 2 by alpha whole to the power of 1 by 2 we are having. Now just observe clearly, when we consider the step index fiber, please see here, when we talk about a step index fiber, so step index fiber we know your alpha is equal to infinite by a, alpha is equal to infinite, I will substitute here, this entire term will become equal to 0, so root 2 into 1 plus 0 whole to the power of 1 by 2, that is equal to root 2, that is equal to 1.414. Bhaiya, but what is the value of V is required to definitely have a single mode fiber is 2.405. Is it clear to everybody in the class? The required value of Vc is equal to 2.405. But what is the value of Vc we are getting here? The value of Vc we are getting is equal to 1.414. Bhaiya, it is obtained by calculating. Please see here, obtained by calculating, and this is required one. So it is not satisfying the condition by taking the value, putting the formula equal to that of single mode. Typically HE11 mode is required. For the requirement of HE11 mode, we definitely replace this root 2 value with which one, Nana? Your root 2 value will replace with 2.405. Okay, so please carefully observe here, I am replacing your root 2 with 2.405, then putting your value is equal to 2.405, your Vc right now changes like this, Vc is equal to 2.405, see the change, the change is V converts into Vc and that Vc value is equal to 2.405 into 1 plus which value 2 by lambda whole to the power of which value 1 by 2 whole to the power of 1 by 2 we are having. So, Vc is equal to 2.405 into 1 plus 2 by alpha whole to the power of 1 by 2 is present, which is the formula we are using for converting your multimode fibers into single mode fibers we are having. I hope everybody in the class understood this. I am explaining once again Bhaiya, please try to understand. By taking the calculation we are getting V is equal to 1.414. But what is the required VV required for having single mode operation? 2.405. Study yesterday's topic. 2.405 is required, but we are not getting 2.405. You are getting 1.415 to overcome that drawback and to have the mode. Single mode is present only when V is 2.405. If less than that or greater than that, we don't have any question of having the mode. So therefore, to have a single mode, you are replacing this root 2 with 2.405. Therefore, root 2 is replacing with 2.405 is the formula for conversion multi-mode into single mode. Am I clear na? Okay, now see here Bhaiya. I am just writing here to make it clear. MMSA, the different color. So blue. MMSA, if you want to convert your MMSI fibers, please see here. MMSI fibers into SMSI fibers, then definitely you know that your alpha value is equal to infinite we are having. When you put alpha is equal to infinite, so 2 by infinite is becoming 0, then your Vc, the amount of Vc we are having is 2.405 is present. When you take Vc is equal to 2.405, definitely your MMSA fiber is converted into SMSA fiber. Okay, so when you want to convert MMGI fiber, see here MMGI, what is MMGI? Multi-mode gradient index fiber into SMGI fiber, single mode gradient index fiber, we want to convert it. Then what is the formula, Nana? The formula is given like this. So nothing is given, then the default alpha is equal to how much? 2 we are having. Put alpha is equal to 2, 2 and 2 will get cancelled. I am writing here your Vc is equal to 2.405 into the value is equal to 1 plus 2 by 2 whole to the power of 1 by 2, and that value is given equal to that of 2.405 into root 2 is the expression we are having, and this value into root 2 value we can have, which is said to be called as so this value you can take the Vc, we will convert MMGI into SMGI. So I request all the students, please try to understand this part. So what we study in the topic is conversion of your multi-mode step index fibers to single mode step index fibers. Okay, please copy it, Nana, all of you. We will solve the numericals. Anjunaik, I will explain to you very clearly how non-uniform velocity create interference to you. It's very simple. When they travel with non-uniform velocity, what happens is different modes will travel with different speeds and they arrive at different times. When they arrive at different times, what happens is pulse is spreading. The spreading of the pulse will going to be creates the interference with the other light pulses. Once copying is completed, please put a message. Right. I have a small question for you. Which type of fiber is preferred? We study about 3 types of fibers: SMSI, MMSI, MMGI. Please all of you put your answers in the chat box. SMSI, MMSI or MMGI. Which fiber is used out of these 3 in optical communication system? Okay. Yeah, I am waiting for your answers. Please all of you put it in the chat box. You are seeing not light frequency, we need to change the V number of the fiber or value of the fiber we need to change. Normalized frequency, V number has to be changed. Justify your answer also, why you are putting that fiber. Justify your answer also, why you are putting that fiber also. Komal, correct answer. Pranav Vardapande, correct answer. Pranav Vardapande, correct answer. Shubhra Pandey, correct answer. Shubhra Pandey, correct answer. Right. See here, the correct answer is SMSI. I give the justification. Just see here carefully, guys. In SMSI fiber, your A value is less, delta value is less, lambda is going to be very high, very high. We take about the lambda. Why lambda is high? The reason is very simple, such that your V value. What is V value? V is equal to 2 pi A by lambda into NA. Dekho bhaiya, if you will make my lambda value is very high, then V value decrease. Then number of modes Mn is equal to alpha divided by alpha plus 2 into V square by 2. Observe carefully. For example, if you are writing that your V value is decreasing, the number of modes Mn is also decreasing. Number of modes are decreasing, light travels with uniform velocity throughout the fiber. Only one mode is there, travels with uniform velocity. There is no alternate for it. So we can understand clearly such that your Mn is equal to that of only one mode is present, and that is going to be travels with uniform velocity throughout the length of the fiber. So what is the main important point here? So here is very simple, lambda is high. Please observe it. Lambda is high. If lambda is high, your frequency is less. Why? Lambda is equal to C by F. Lambda is high, frequency is less. Less frequency in optical communication means, you know, it is 10 power 12 hertz. 10 power 12 hertz means it is at IR. That's why optical communication is using at IR region, infrared region. Repeating once again, please see here. So you want to get your SMSI fiber, only one mode is present. See, only one mode is required. V will be less, Mn will be less. When Mn will be less, that means your lambda should be high. The lambda should be high, then frequency is less. Which frequency? Optical frequency. Optical frequency is less means it is operating in which region? IR region. That's the reason we are making to operate our optical communication system in IR. IR stands for the infrared region. Clear, Nana? I told in the classroom such that when we go into the concepts, I explain each and everything, why you are studying about IR and remaining all the things also. Okay, so this is the first one I need to explain. So delta is high, therefore it is called IR region we are operating. Then automatically what happens to the V? V is less. If V is less, Mn is less. Mn is less means only one mode is present. One mode is present means what happens means it will going to be travels with there is no ISI, no intersymbol interference or no pulse spreading. There is no pulse spreading means we can tell that there is no errors we are having. There is no errors is present. The errors present is going to be very less we are having. There is no errors, bhaiya. No errors in the sense means nothing errors occurs with the intersymbol interference. Next one is see here, MMSI fibers. Dear students, thoda concentrate karo bhaiya. The value of A is large, delta is large, lambda is less, V is large, number of modes are high, and that number of modes are given as formula given as V square by 2. This number of modes are present, and we can tell another important thing, ISI is present. Okay, ISI exists. ISI exists means what happened to the error bhaiya? Errors are high. So because errors are high in communication system, you don't want errors, so errors are high. So we have the high number of errors are present. Okay, so this is what the case we are having. So once we talk about MMSA fiber, this is the scenario. So next one is we discussing about the MMGI fiber. Please see here, MMGI fiber also A value to be high, delta value to be high, lambda to be less, V is to be high, Mn. Your Mn is equal to V square by 4 taking the profile, parabolic profile. Your Mn is equal to V square by 6 taking a profile called as triangle profile. Here also not uniform velocity, ISI presents, but errors are less. The reason is amount of dispersion is not high. So errors are less we are having. So here ISI exists is high. ISI exists is high. ISI present is less. Therefore errors are less we are having. Observe bhaiya, entire class what I explaining, yesterday's topic and today's 2 hours of topic completely present in this case. Completely present in this case. We observed clearly such that we are having a 3 types of fibers. Out of the 3 types of fibers, optical communication system, changing the color of the pen, optical communication system, OFC, optical fiber cable, okay, fiber cable uses in optical communication is which one? SMSI. And for this topic only I am explaining all the cases, all the scenarios to you in the classroom to make it clear about what is the value. And here what is the value of V, Nana? Value of V is equal to 2.405, then only we will have one mode, that mode is called HE11 mode. Please write down that part also. Okay. Soumya, speed is not fast in MMGI, speed is fast in SMSI, because only single mode it will goes very fastly with uniform velocity also throughout the length of the fiber. Clear na? So, what is the answer right now? Answer is SMSI. Students who put SMSI, answer is correct answer bhaiya. The preferred fiber in the entire optical communication system is SMSI. SMSI fiber. Okay, please copy it. We will start solving the numericals. Please copy it. We will start solving the numericals. By once copying is completed, please place a message. Complete copying. So, students, take a break of 20 minutes. Okay, assemble here by 20:23, like 8:23. Okay, so take a break. We can see after the break the numericals. Okay. Break.